High performance computing. Performance computing is computational facility substantially more powerful than current desktop computer. The parallel computing. So, when we need high performance computing, for example, to do a high number of operations per second. What does high performance computing study? Include following subject. For hardware, we learn computer architecture and network connection. Then for software, programming paradigms and language or middleware. Now we go to the history. Initially, all computers were designed for HPC. Design special hardware, for example, special processor, special memory, and so for the nowadays, specially designed hardware is not as good as using more processor. So we use chip processor.
Parallel computer architecture. This is no issues about load balancing. I/O is straightforward. All memory areas are equally accessible to all. Processor-to-processor data transfer are done using shared areas in memory and its limited scalability. Distributed address space. Processor-to-processor data transfers are done over internal network topology. Imposed memory locality, high scalability, load balancing issues, I/O difficult. Memory with multiprocessor, and this one is 4-node PC workstation cluster, which is as network switch, and it has 4-node PC. This is the top 10 most powerful computer. You can get this when you go to link www.top500.org. This is the example of key terms and concept. You can see the picture with the problem, instruction, and CPU. This is the formula for scalable speedup, which is execution time on one processor divided by execution time on n processor, and basic definition has 3, which is high capacity parallel computing, high capability parallel computing, and cooperative computing. And this is the basic definition for these main classes of computing. There is 3: high capacity parallel computing, high capability parallel computing, and cooperative computing. This is the graph of strong scaling versus weak scaling. You can see weak scaling is the brown color and the strong scaling is blue color. This is model of parallel processing. Some alternative model of parallel processing there are for SIMD, vector machine, systolic, and data flow. Share memory, multiple thread, static or dynamic, fine-grained, open, empty, distributed, shared memory system, and covered in segment tree. As you can see, this is communicating sequential processes. Speedup can be defined for 2 different type of value. 1, throughput, and 2, latency. Speedup is defined differently for each type so that it is a consistent metric. This is the formula for speedup, S equals to TO divided by T new. Superlinear speedup. Sometimes a speedup of more than P when using P processor is observed in parallel computing, which is called superlinear speedup. This is superlinear speedup. The time spent communicating between processors relative to the total time spent performing parallel computation is called a communication overhead. This is the formula for concurrent tasks that would be necessary for purely sequential execution. Performance issues. Throughput computing performance measured as a total workload performed over time to complete. Thank you for watching. Bye.
Created using Powtoon.